First, I want to thank everyone for joining me tonight. As Stacy said, I'm Joel Kearns. I have the honor of leading NASA's plans and work for the exploration of the moon. And I put what I think is an iconic photo up here first. This is a photograph of Buzz Aldrin on the surface of the moon taken by Neil Armstrong during the Apollo 11 mission in July of 1969. And this was the first time people from Earth ever went to another planetary body, in this case, the moon, Earth's satellite. And there's some very interesting things in this photo to me. One is that he's in a spacesuit and he got to the moon in this relatively small ship called the lunar module. And you can see a thing in front of him that looks like a sail or a piece of foil. And that is called the solar wind experiment. It's one of the first experiments ever performed on the surface of the moon, besides simply taking samples of the surface itself, rocks and the soil that's called regolith. And it's interesting in this photo that you've got an American astronaut who was a military pilot before he became an astronaut, and he flew to the moon in a spacesuit and a spaceship. The spaceship was designed by NASA and also the Grumman Aerospace Corporation in New York. And the experiment that's in front of him was provided by the government of Switzerland. So the things that are kind of interesting about this photo is here's one of the first images of a person on the moon. It's an American military pilot, came in a ship that was really designed by the government and a giant company in the United States working together with an experiment that came from another nation on the very first flight to the moon. And this is somewhat similar to, but actually very different from the way we're proceeding to do scientific work on the moon today. Today, we're pursuing learning about the moon, understanding science of the moon, using robot probes, which you probably know since the time of Apollo, we've used really extensively around the solar system, flying to Mars, like the rovers on Mars, flying to the giant planets Jupiter and Saturn, flying all over the solar system with robots. But we're also going to do some science on the moon with astronauts. But the thing that's interesting is that now the astronauts come from all different walks of life. They're not just former military pilots. The way we will get to the moon is a combination of government-owned ships and also ships built totally by private industry working in partnership with NASA, or sometimes even building their own ships, and then NASA decides to use them because they're really good quality ships instead of making our own. And with a much tighter tie to other nations around the world who will be providing parts of those ships as they take the astronauts up to the moon and to even further destinations. So you'll see photos like this that are new photos in a couple of years of American astronauts on the moon. When you see those photos, think about this one. You'll be surprised both at how different they'll be and in some ways how similar it'll look. Could you go to the next image, Stacy? The United States government has decided to name its effort to go back to the moon and then onward to Mars with people, Artemis. Artemis, if you remember, the original effort to land a man on the moon in the 1960s was called Apollo, named after the Greek god Apollo. Artemis was the sister of Apollo. And Artemis, our new Artemis, is the first step in our new era of human and robotic exploration of the solar system. But again, it's going to be done now with commercial, industry, and international partners. Our goal here is to establish an ongoing, sustained presence on the moon to solve longstanding scientific questions and also to prepare for eventual human journeys to Mars. And not just to Mars, but to places in the solar system even farther away than Mars. You might have enjoyed watching the lunar eclipse this weekend if you had good weather. And here's an image here of the moon. This is on the near side of the moon. You know, the moon the moon orbits around the Earth once a month, and the moon also rotates around its axis once a month. So it turns out we only see one side of the moon. In this image, this is the side that's lit up that we're looking at. You know, if it was the other side that was lit up, we wouldn't see the moon. It would all be dark against the sky, or it'd be, you know, a thin crescent. But Artemis is going to focus not only on solving scientific questions that scientists in the United States have proposed for decades, but also to see how we can really learn to live off the land in the future on another planetary body as a way to bring that place into our economic sphere of influence and to make it a place that we can live and work and get value out of. Could you go to the next chart, please, Stacy? Now, I mentioned to Stacy when the talk started that in Florida, just a few minutes ago, there was a launch of a new spacecraft. The spacecraft is provided by the Boeing Corporation, and it is a test run without people of a new spacecraft called Starliner that will eventually bring people up to the International Space Station. The International Space Station is our multinational research lab and scientific complex in space. It's been orbiting and being used for over 20 years. And people scientists and engineers from many nations go to the International Space Station to carry out scientific investigations. And also understand how people's bodies change when you're up in space, and to learn how to prepare to go back out to the moon and to further destinations. The launch that happened in Florida just a few minutes ago, as I said, was just a new type of spacecraft. It's not only a spacecraft that is a design from a company and not the US government, but it is another way to get to the space station. We have another company that you've probably heard of, SpaceX, which also has their own spaceship, which looks very different from Boeing's spacecraft, that we use today to safely bring our astronauts up to the space station and bring them back to Earth after they complete their research. You probably see on TV people floating around the space station doing work, and you think, wow, it's so far away that there's no gravity there. There actually still is quite a bit of gravity at the altitude the space station's at. Everyone floats in it because the space station is slowly falling around the Earth. Space station's going very fast over in orbit around the Earth. It's falling, but it keeps going forward so fast it falls all the way around the curvature of the Earth, and everything just floats within it. But what's interesting is it actually isn't all that far away. If you could go to the next chart, please, Stacy. So Earth is about 8,000 miles in diameter, if you were to look at it, if you were far away from the Earth and looking at it. And the space station is only 250 miles over the surface of the Earth. So imagine the space station going around in a circle over the Earth. It's actually still pretty close to the Earth. It takes probably about 10 minutes to actually fly a rocket from the surface of the Earth to get into orbit around the Earth. It takes maybe a day or two to line up all the orbits once you are in orbit, so that you can have a spaceship dock to the International Space Station. So the space station is relatively close to us. It's pretty straightforward to get to, and if for some reason you had to come back really quick because you fell ill, you could get back pretty quick. You could get back in about an hour and a half to 2 hours in an emergency. You could jump into your spacecraft and come right back to Earth. So we go to the next image, please. The moon, however, is about 240,000 miles away, or about 30 Earth diameters away from the surface of the Earth. Could you go to the next image, please? So here's the Earth and the moon to scale with each other. I bet you can barely see the little gray moon on the right side of the image, but it's 240,000 miles away. It takes about 3 to 5 days, depending on how you go out there, actually to get from orbit of the Earth to go into orbit of the moon. And if something were to happen to you out there where a piece of equipment broke, or you had to get back quickly because of, say, some medical issue, well, you can't get back sooner than 3 to 5 days. So it's really important that we learn not only how to travel out into space to these really long distances, but how to reliably have our equipment operate there, how to plan and manage and do our work ourselves maybe without such close contact back to mission control and the ground on Earth, because it's a long way away when you work there, and it's quite a bit of time to get back. And Mars is much, much further away than the moon is. If it takes, as I said, 3 to 5 days, say 3 to 6 days to get to the moon or back, it can take at the fastest 9 months to get from Earth to Mars. And depending on how the planets are aligned, it could take a lot longer than that to line everything up so you can come back from Mars to Earth. Go to the next chart, please, Stacey. So some people they hear my talk about we're going to go explore the moon for science with robots and with people. And one of the questions I have is, well, why are we going back to the moon? People talk about going back to the moon. And some people say, well, haven't we been there and pretty well done everything that we wanted to do in the moon? Well, if you look at all the places that the Apollo astronauts went and some of the few robot probes, like the old Soviet Union's lunar probes, or the more recent Chinese probes that have gone to the moon to do scientific experiments, maybe 5 or 6% of all the lunar surface area has been looked at. And for example, 6% of the total surface area of our planet Earth would be like the equivalent of, say, North America. So this would be thinking that you went, say you came from someplace else and you landed on Earth and you landed in the United States or Canada, and you looked around and took photos and left, and that meant that you saw everything that existed on Earth. You didn't see anything else. Could you go to the next chart, please, Stacey? And a little couple of circles popped up here to show roughly the places where we've landed or other nations have landed. And that size, if you spread out that whole area, that size is roughly the size, say, of North America. If you go to the next chart, please. So lunar exploration started around in the Apollo era in the 1960s. First, the United States and some competitors like the Soviet Union sent robotic probes that flew around the moon, went in orbit around the moon, took images. Some of them crashed on the moon deliberately. It was a test to see if they could just take data on their way down to the moon before anyone knew how to land on the moon. Then eventually landed on the moon. We landed, the United States landed very trained pilots who were trained as explorers and as geologists to go to the moon. The Soviet Union landed some robot probes that were robotic rovers or ways to bring small samples back from the moon. And later, the Chinese government, just the past few years, has done that also. But in the United States, lunar exploration started out with two really big advantages, really, compared to our great exploration of other planetary bodies like Mars. The first is that we actually went with people. And these people really looked around, took initiative, and explored. As I said, the astronauts, even though they were originally military pilots, jet test pilots, they trained really hard to understand what science to do in the moon, and they were incredibly good geologists in the voyages that went to the moon. The other big advantage we had is that because the moon was so close to Earth, we had the technical ability to bring lots of samples back. We brought back about over 800 pounds of rocks, of soil, of particular things that people saw, glasses, things like that. And from that, they were able to get a very good idea from analyzing all that lunar material on Earth to answer some of the questions they had at the time about where did the moon come from and why does it look the way it does. But it also generated a lot of other questions. And it was realized that the moon is really, in some ways, a way for us to look back at the history of how Earth and the rest of our solar system formed and how it got to be the way it is today. If you could go to the next chart, please. So since Apollo in the United States, we've been studying the moon from orbit around the moon. We really haven't gone down to the surface since 1972 when the last two astronauts left. For one thing, years ago, it was pretty expensive to go. It was difficult to go. Technology has changed a lot since then. When we go back to the moon, even with robot probes today, we're going to go back with probes built by companies that are really doing it as a service to NASA, as opposed to NASA building its own probes to go to the moon. We will have two companies, the first of 4 companies that we are working with that will send their own landers that they designed and built themselves with scientific instruments provided by NASA to land at various points on the moon later this year, near the end of the year, and then several more in the year 2023 and so on into 2024, 2025. 2022 will really be a year of the moon. I don't say it's the year of the moon because you're going to be seeing a lot of scientific work on the moon starting this year and going for the foreseeable future. But because we have had robotic probes flying around the moon taking photos, we have a pretty good global view of the moon now. We actually know much better now where to go on the surface of the moon to answer certain scientific questions. And we also we need to go to the surface to answer some of the next big questions. So now I'm going to talk about a few ways we're going to go to the moon and what we're going to do when we get there. All of our probes up to now, at least in the United States, whether it was Apollo or robots, have landed on the near side of the moon. As you can imagine, that was probably the safest place to send our astronauts in the 1960s. But as you can see from these images, the near side and the far side actually look quite different. They were probably formed in very different ways. And one of the things that jumps out when looking at the moon, of course, is all the craters you could even see from the Earth. Well, if you're very close to the moon, you can see way more craters than you can see from Earth. They cover the surface of the moon, both on the near side and the far side. But you can also see that that look like these darker flat areas on the surface on the near side that you don't see when the far side of the moon is lit up. So one question, of course, is how are they different? We have samples from the near side of the moon from different areas. We don't have any samples from the moon's far side. We've never done experiments on the far side of the moon. That's something we'll do for the first time with robots about the year 2024. And eventually astronaut crews will also go to the far side to really understand what's there. If you could go to the next image, please. Here's a slightly different view of the moon taken where there's data overlaid from robotic probes. The view on the left is the south pole of the moon, and the view on the right is the north pole. And you can see they look kind of similar. They don't look exactly the same, but they don't look as dissimilar as the near side and the far side. Everywhere on this that you can see a spot that's blue or teal, that is where there's been a reading where robot probes from far away have sensed the presence of water or the hydrogen or oxygen chemicals that make up water. So this was a surprise that we started getting about 10 years ago, way after, or even a little bit longer than 10 years ago, way after the Apollo missions though, that at certain areas of the moon, at the North Pole and the South Pole that are very cold due to the fact that because of the way the moon orbits, some of those areas never see the sunlight at all. So the sun never heats up those areas. It appears that there's water or the chemical constituents of water that are trapped in those cold, dark areas. That's something we didn't know about when we first started robotic exploration or when the Apollo astronauts went to the moon. And as you can imagine, water could be very useful to actually do work on the moon in the future. If you could go to the next chart, please. Now, as part of this Artemis effort, we're going to be working with industry in the United States and international partners to both put robotic systems on the moon to answer questions and send astronaut crews to the moon to explore. You can see here a list of all the different contributions that different groups are bringing together for Artemis. NASA is building with its large aerospace contractors a new big rocket called the Space Launch System that will take with it the Orion spacecraft, which is designed specifically to take astronauts to very far away destinations in deep space. They'll be able to travel out to the moon. Later this year, well, pretty soon this year, there'll be a test flight of the unmanned version of the Space Launch System rocket and the Orion spacecraft to check out its systems in 2022 on a big loop around the moon as a dry run before astronauts head out on the first mission in about 2 years in 2024. But in addition to the rocket and the spacecraft, we also have to have a special vehicle to actually go from the orbit of the moon and actually land on the surface. Orion was never built to land on the surface. It was just built to go into deep space. So we'll have a spacecraft built by SpaceX, which they will own, who will work with NASA so that SpaceX, under contract to NASA, can take NASA's astronauts to the surface of the moon to do scientific research. They'll do surface operations in spacesuits. There will be a mini space station that NASA will build with international partners, a jumping off point near the moon called Gateway, smaller than the International Space Station and very focused not on research in microgravity like we do on the International Space Station, but a jumping on point and an assembly point for people going to the surface of the moon or to destinations beyond the moon. On the lower left, as I said, we have robotic probes that will go to the moon that are actually built by companies in the US, not NASA. Those are built under a contract called Commercial Lunar Payload Services, or CLPS, where NASA contracts with a company to give us the service of sending our equipment to the moon, and it's up to them to decide how to do that. We'll have to stay in close communication with the astronauts and with the robotic spacecraft through what's called space communication and navigation. We'll have updated roving vehicles, some which will look like dune buggies that the astronauts will drive in, and some which are actually like mobile homes where the astronauts can go long distances in a normal shirt sleeve environment, but then get into their spacesuits to go out and do work on the surface. And then finally, a few years from now, we will establish what's called the base camp of Artemis, Artemis Base Camp, at the south pole of the moon, where we believe we will find those reserves of water that can be very useful for future work. If you go to the next chart, please, Stacey. We already have 4 companies contracted with NASA that will do 7 landing deliveries to the surface of the moon. We have one more competition that we're running right now to take the first American robotic equipment to the far side of the moon. And we will be having competitions so that we have 2 robotic landing missions a year going to scout out regions of the moon every year, starting next year in 2023 for the foreseeable future. Where you can see here a map of some of the company's robotic rovers. Again, these are owned by the companies, not by NASA, that will take equipment to the moon. And you can also see in the middle and the bottom that there's a lot of rovers that are going to the South Pole, one way or another, to look for the resources that are there, water or other volatile elements that could be of use. A major project NASA is doing is a robotic rover called Viper that will specifically carry a drill and scientific equipment to drill under the surface in these cold and dark regions and look for ground confirmation of the presence of water on the moon, so we can confirm all the remote data that's been taken by probes in orbit. Each of these companies, although they are funded by NASA on a contract to bring NASA's equipment to the moon, since NASA doesn't own the landers, they are out getting other people to take their equipment on these same missions to the moon. And we believe that this will start a business with all these companies where nations and companies in other parts of the world will work with American companies to bring the experiments that they want to do to the moon. And that will hopefully create a system where NASA in the future can simply buy the service, just like today you could buy an airline flight personally if you wanted to travel to a certain place. We'd like to be able to buy the ticket that just lets you travel to the moon, whatever you would like. Next chart, please. Here's an artist's conception of the Space Launch System rocket with the Orion spacecraft at the top. If you've watched the news, you probably saw this system being rolled out to the launch pad for checks. It's been rolled back to work on some things that were found at the launch pad. It'll roll back out to the launch pad in a short time in the future. And then we'll have that unmanned test flight of all the systems before we fly astronauts in 2024. This is about as big as the Saturn V rocket that took astronauts to the moon in the 1960s. And future versions of it will be even bigger, so we can bring more and more equipment out to the area of the moon and eventually down to the surface. Would you go to the next chart, please? The very first mission, called Exploration Mission 1 or Artemis Mission 1, will launch from the Kennedy Space Center in Florida, and will go all the way out to the moon. But instead of going to a tight orbit around the moon, like the Apollo missions did, it will actually go into this really long, big orbit called a distant retrograde orbit. So this will allow the spacecraft to stay in orbit around the moon in a giant loop for about a month, checking out all its systems. This particular type of orbit, which will only be attempted for the first time by a robotic probe that should launch the end of this month from New Zealand for NASA, could be used in the future as a jumping off point to go to Mars or to other destinations. So we're using it as the checkout area for our Orion spacecraft before the flight, the next flight that will actually have astronauts fly out to the moon. If you could go to the next chart, please. Once we have started landing on the moon and are flying out regularly every year, we will start building the Gateway small station near the area of the moon. This will have elements of it, much like the International Space Station, contributed by other nations who would like to work with the United States on exploring the moon. we will take our Orion spacecraft and dock it to this station. And then we will have the companies that provide the lunar landing vehicles also send their vehicles out there to dock. Our astronauts will be able to get ready to go to the surface, enter the lunar landing vehicle, go down to the surface. When they're done, bring it back up to this gateway station, and then they can ready the lunar landing vehicle for a future landing, again, refueling it, cleaning it up. They can also get supplies from robot freighters that will come in from Earth and dock to this gateway station. Next chart, please. So there have been longstanding questions about the moon since Apollo that scientists around the world are interested in, particularly scientists in the United States. So NASA has drawn up a plan of what scientific activity will be done on the moon, both by robots and by the astronauts. And we've laid out 7 scientific objectives. I'm going to talk about really the second and the third one. The second one is to understand the nature and origin and character of what are called volatiles on the moon. Volatiles meaning something that can evaporate and get away from you. And in the vacuum of the moon, a great example of that is water, which probably exists as ice under the surface, or maybe ice even on the surface in those cold and dark regions. Another objective is to understand what's called the impact history of the Earth-Moon system. That is the craters. Where do the craters come from, and what does that infer to us, the craters that we see on the moon, about why the moon turned out to be the way it is, and what happened in the same time in the same neighborhood to Earth. You know, we don't see a record of a lot of craters on Earth because of Earth's weather, but we are in the same neighborhood as the moon. Pretty well everything we should see that happened on the moon, Earth was probably subjected to too. So by looking at things like impacts and craters on the moon, we can uncover some of the past history of Earth and get some insight into why our planet is the way it is today, what is really existing under the surface, far under the surface. We can at least get some ideas from looking at our nearest neighbor, which is our satellite, the moon. And there are many other objectives that scientists have identified for the work that both robots and astronauts will do on the moon, but I won't read through all 7 or all the details beneath the 7. I'll talk about number 2 and I'll talk about number 3. If you could go to the next chart, please. So understanding volatile cycles. So the moon represents all different types of sources and sinks of water in the solar system. We don't really know if the water came from comets or asteroid impacts, or it came from hydrogen from the sun reacting with oxygen in the minerals of the moon, or whether it came even from volcanoes from the moon. So what we will do is look at all those things. The astronauts will have particular studies to do, as well as the robot probes, both on the surface of the moon and drilling down deep underneath the surface of the moon. If you go to the next chart. Again, the sources and where their distribution on the moon of volatiles such as water really isn't well known. It's only inferred at or hinted at by the remote probes taking data from orbit or from Earth. And the sources of where these things came from can affect how the deposits are distributed and how accessible they might be as resources. Now, why might you want water on the moon? We have a lot of water on Earth. Well, the reason, of course, is that if you had water on the moon, you could process it and you could drink it. You could break it into its component chemicals, hydrogen and oxygen, both of which you can use as rocket fuels. The propulsion is the hydrogen and the oxidizer is the oxygen. You could use the oxygen and turn it into air for people to breathe. And all of that you could get from water on the moon would be similar things you didn't have to bring all the way from Earth in a rocket. So if there really is reachable, usable quantities of resources such as water or perhaps metals or other things, they could be made you could make use of them on the moon after you refine them and not have to truck them up away from the Earth to get out into space. It's much easier to get things off the surface of the moon because of its lower gravity than from the surface of the Earth. So whether you want to use them on the moon or you want to use them in space, it'd be much more straightforward to get them on the moon than to bring them up all the way from the surface of the Earth. If you go to the next chart, please. As I said, we have a particular new robotic system that's being built today to be taken by one of the commercial robotic landers to the moon, called the Volatiles Investigating Polar Exploration Rover, or VIPER. Viper is going to go into these dark and cold areas that have not seen the light, and it's going to characterize the distribution and state of lunar polar water and any other volatiles it finds in those what are called cold traps to understand their origin. And we want to be able to get enough information to have definitive proof of what state the water is in is on the moon, and to take measurements at enough places to get a feel for how well distributed it is in these different cold, dark, what are called permanently shadowed regions on the moon. We will, again, deliver it to the moon using a commercially built lander, not a NASA lander. It's going to launch at the end of 2023, and it will work for about 3 months on the surface of the moon. And it's got a variety of scientific instruments built in it, so we can get hard answers to these questions about, is there water, and what state is the water in? Is it usable the way it is? Is it near the surface, or is it far below the surface? Viper will not only have scientific instruments on it, but it'll have a drill that's more than a yard long to drill deep under the surface of the moon, because it's possible the water may not exist quite at the surface, but a little ways under the surface. If you go to the next chart, please. Now, the other one of the other things we want to study, again, is the impact history of the Earth-Moon system. That is our local neighborhood. So impact craters, they occur on Earth. There are some on Earth, like Meteor Crater in Arizona. Folks have seen photos out or visited. But many of them are erased just due to erosion and weather, which means that the moon actually, because of there's no air, there's no weather on the moon really, it retains a record going back billions of years of all the different impacts and all the changes that occurred in our local region of space. So scientists are dating the age of different lunar rocks to understand when those impacts actually took place, to try to get a feel for, were there times when there were a lot of meteor impacts in our solar system, or maybe even very near the Earth and the moon? Perhaps did those correlate with changes that we see in the fossil record on Earth, or are they totally different from that? We'll be able to get information about the impact record on the moon and interpret it in relation to Earth's and the moon's history. One question, for example, is, did these impacts come at particular times repeatedly over and over, or are they just random? At least some evidence we have suggests the impacts might occur on a certain period, which could help us predict when more impacts would occur in the future. Next image, please. And of course, one of the things that was discussed since the time of the Apollo missions that scientists would like to get more data on is to verify what's called the giant impact hypothesis, the idea that a Mars-sized body actually slammed into the prehistoric Earth more than 4 billion years ago, and what came out of that was Earth and our moon, the Earth we know today, and our moon, our satellite. Would you go to the next image, please? One place we'd like to go visit on the moon to understand these impacts is a special area near the South Pole, again, really nearer the far side of the moon, called South Pole Aitken Basin. The reason this appears to be the largest, oldest, clearly recognized giant crater impact basin on the moon. You can see in the diagram how big it is, with the South Pole all the way to the bottom center of the diagram. Whatever happened there, it really completely resurfaced a really large portion of the moon over many ages. A gigantic area was changed. So by understanding when things happen and what exactly happened, again, we can probably figure out what the violent history has been in the Earth-Moon system, what we can see on the moon today, and how that implies similar things that happened on Earth long, long ago that affect why Earth is the way it is today. If you go to the next chart, please. So we have a number of things getting ready to go to the moon. As I said, 2022 will be a year of the moon. Today, and for actually the last 13 years, we've had a photography probe in orbit around the moon called the Lunar Reconnaissance Orbiter, taking photos, taking scientific measurements. Soon this year, as I said, the later end of this month, we will launch a small robotic probe called Capstone that will go into orbit of the moon, the first time of the special orbit that we'll use for the new Gateway space station, to make sure we understand how things work in the very particular orbit the Gateway will go into. We will then have the Artemis 1 launch, the new rocket and the new spacecraft, an unmanned mission to go out past the moon to ready that equipment and check it out. It'll be followed in 2024 by the Artemis 2 mission, which won't land on the surface, but will take humans out to orbit the moon for the first time since 1972. We will then start building the space station up called Gateway in the area of the moon in pieces. We're going to start off with its power and propulsion system first, and then go on to its habitation areas where the astronauts can work without having to wear spacesuits. And then around 2025, we'll have the first landing of American astronauts on the moon to do scientific research since the Apollo 17 mission in December of 1972. They'll start to answer many of the scientific questions. They will start to really explore the regions of the moon and the South Pole where people have never been before. And I think what you will see when you see images of that in just a few years is that it's going to look really different at the South Pole than the images you see of the Apollo astronauts. As I mentioned in the beginning, all the Apollo astronauts landed on the near side of the moon near the equator, or at least they didn't land near the poles, the North Pole, the South Pole. They landed during the 14 days when the near side is lit up. Because the moon goes around the Earth in about 30 days. Daytime, the day of the moon lasts for 14 Earth days, and that's followed by a 14-day nighttime on the moon. So when the Apollo astronauts landed, they would land in missions that would last a few days, say 2 to 5 days. They would get all their work done during daylight. The sun really didn't, and the Earth really didn't move much in the sky. And they would leave and come back. When the astronauts go to the South Pole and start working at the South Pole, they're going to be working at a place of really stark long shadows. The sun is going to be really low in the horizon, as will the Earth be really low in the horizon. And it will be really different, where our astronauts are having to learn how to prepare to work at a place that no one's really been to before. And when we send robotic probes starting next year to the South Pole areas to prepare, some of the images that are going to come back are going to look really different from images that were taken from the Apollo astronauts in the 1960s and 70s. If you could go to the next chart, please. Now, one of the reasons we want to go to the moon, besides to answer scientific questions and learn to live off the land and really exploit the moon, is to get ready to go to Mars. But going to Mars really is hard, much harder than going to the moon. If it wasn't hard, somebody would have done it already. And there's a number of reasons for that. One is that it takes a long time to get there. The astronaut crews that leave Earth orbit to go to Mars, it will probably be 800 to 1,000 days from the time they leave to the time they come back. They will have to make sure that their ships are reliable, rugged, can be repaired, and will shield them, for example, from radiation, solar flares, things that could hurt them on the journey out there and back. We have to learn how to land really big spaceships that include people on the surface of Mars. We land pretty big things on Mars right now, like the Perseverance rover and the Ingenuity helicopter, but those are about the size of a small car. They're not giant spaceships, or even the size of spaceships that took astronauts down to the surface of the moon in the 60s and 70s. So we're gonna have to learn how to land really big, heavy things on a planet that has some atmosphere, not breathable air like Earth, but it's got enough atmosphere to make it tricky on how to land. You probably noticed our robotic probes land using a combination of parachutes and rockets. It's a little bit more straightforward to re-enter and land on the Earth with gliders or parachutes, or even to land on the moon. There's no air on the moon, so you just have to use rockets. It's more challenging to land on Mars. It's got enough air on Mars, even though we really can't make use of it, that makes it really difficult to land big things. There will be a long time delay. Even at the speed of light, there'll be a 44-minute maximum two-way communications delay between talking from ground control to the astronauts on Mars. There's a very short time delay, from Earth to the moon. The moon is pretty close to Earth, but Mars is really, really far away. Particularly, and there'll even be blackouts of communication every 26 months when Earth and Mars are on opposite sides of the sun, and you can't get a radio signal past the sun to get to Mars, and vice versa. And we'll have to, again, if we can't learn to live off the land, first on the moon and then to Mars, we will have to get a ton of things with us: food, water, oxygen to breathe. It will take a lot of preparations to be able to get to Mars. If you go to the next chart, please. However, we're trying to learn from living on the moon in Artemis how to get ready to go to Mars. We know, for example, we need a landing system to go to the moon. We know you need one of those for Mars. We will need rovers so our astronauts can travel to far different distances for different scientific studies. We'll need that on the moon. We will need a very similar system on Mars. We're going to need we need ships to get our astronauts from Earth to the moon. We need ships to get our astronauts from Earth to Mars. So everything we have planned out, working with our international partners and American industry, is to be able to do a good job addressing these scientific questions on the moon, exploring the moon, understanding what resources exist on the moon, but with an eye to how do we apply how we did that for when we send people to Mars on the next big step. So you can see a lot of the things that we're learning about on the moon, we're going to be able to directly apply the knowledge or even the systems we engineer to get all the way out to Mars as the next step. Could you go to the next chart, please, Stacey? So when we look at the moon, we look at it as a place to explore, to answer very fundamental scientific questions about how Earth got to be the way it is, how the other planets got to be the way they are. But it's also a place potentially we will be able to call home someday if we can really learn to live off the land. And it's certainly a stepping stone on the way to other destinations. As you can see here in the image, the moon lights the way to Mars. We see our work on the moon that you'll see in the next few years as being part of the steps we're doing to get to Mars and to destinations even further beyond Mars in the future. I want to thank you for taking time to listen today.